Homework Help with Jen. We're doing Chapter 5, Problem 73. I wanted to do another one of these gas stoichiometry type problems. And I like this one because it makes you come up with the equation. But I figure that that might also be what makes this difficult. So part A says to come up with a chemical equation for the reaction. This is that hydrogen cyanide is prepared commercially by the reaction of methane, ammonia, and oxygen at high temperature, and that the other product is gaseous water. Okay, so let's come over here and think about that. I'm getting kind of a funny glare here, so hopefully everybody can see this well. So first of all, they tell us that we start with methane, CH4 gas, and ammonia, NH3 gas, and oxygen gas, and that with this we make hydrogen cyanide. So by that they mean the hydrocyanic acid, HCN. Okay. And gaseous water, H2O. Alright, now the tricky thing here is that we have to balance this. Okay, so well, right now we have one nitrogen and one carbon, one nitrogen and one carbon, that's great, and one hydrogen. So I think that actually what we can probably do is we can probably just balance this over here with the H2O. So here we have one hydrogen, and on this side we have 4 plus 3, that's 7. So if we use 1 in our HCN, then we have 6 left over. So if we put something here that says 3, that gives us 6 more hydrogens and 3 oxygens, and so I think the easiest thing here is to just say 1.5 oxygens. Okay, so that being said, that's probably the easiest way to do that. It says, what volume of HCN gas can be obtained from the reaction of 20 liters of CH4 and 20 liters of each one, basically. Okay, and we want to know the volume of HCN gas. That's where they tell us it's gas. Let's say, okay, well, what volume? Okay, guess what? This problem is not nearly as difficult as it says. There's a total trick to this. It says the volumes of all gases are measured at the same temperature and pressure. Okay, so remember, Avogadro's law says that there's a direct link between the volume of gas and the number of moles of the gas. Because there's a direct link between these, we don't care what our molar masses are. All we care about is our mole ratio. So if we look at this, this one says that we need 1 to 1 to 1.5. Okay, that automatically means since we need 50% more O2, this would be like saying 2, 2, and 3. So another way of saying this would be 2, 2, and 3 for our mole ratios. So if this is 20 and 20, then we would need this one to be 30. Since it's not, then our oxygen is our limiting reactant. Okay. Alright, so if we keep going through, so we say we've multiplied everything by 2, then this would also be 2, and this one would be 6. And they want us to know, so these are our new mole ratios. Okay, so they want us to say, okay, well, how much volume can we make with our HCN? So we can say, okay, well, since my oxygen is my limiting reactant, then 20 liters of O2. Okay, now I put in my mole ratio. I can use my original one. This is 1.5 moles of O2 per 1 mole of HCN yields. Okay, so this is actually, you could also say, since moles and liters are linked, that 1 liter of HCN is to 1.5 liters of O2 because there's a direct link there. Okay, so this tells us 20 divided by 1.5 is 13.3. This tells us that we'll make 13.3 liters of hydrogen cyanide gas, okay, based on everything being the same temperature and pressure.